Thank you very much. So, my friend Alice actually came to me and asked me if I could help her build a phishing detection company. And because I've actually built a lot of these things before, I wanted to give her a little bit of advice on some of the lessons learned and all the mistakes that I've made so that she doesn't make them as well. My name's Daniel Linder. I'm the Senior Director of Data Science at Tessian, previously the Head of Data Science at Adyen, and I've been working on building machine learning systems for as long as I can remember. And I'm here today to talk to you about the lessons learned on the journey to a machine learning platform. And so the first lesson that I gave to Alice in terms of what she should do, how should she start, it's to be the algorithm. Actually put some headphones on, try to focus, and really try to understand what's coming through. You have emails coming through, and you have to understand what is causing this email to be malicious, what type of attack is it, what is causing it to be safe, to really understand all of the things that make these emails what they are. Really sit down. Don't try to rush into building a very advanced system right now. Just try to be the algorithm yourself. It will go very, very far. Label the emails and really understand them. So she did that. She sat down, she labeled the emails, and she's like, hey, Daniel, what do I do next? Because now it's just me. What do I do next? So then I came to lesson 2, which is build the whole end-to-end system first. Don't try to build this crazy algorithm. That's going to be something you're going to do later. You have to build along the way and understand actually what's going on for the end-to-end. Too many times you'll have companies that are trying to build the algorithm part of it, and they don't understand that actually the pipelines and all the things that go into the system are the things that are going to break along the way. So start by doing it like that. It's much, much better. And will help you later on to find out all the problems that you're going to face, find them out early. So fail fast. So she did that. She built this end-to-end system. She's failing quickly. And now she wants to know, well, what's next? So that brings me to lesson 3, which is that good data is better than good algorithms. Now, what often happens is that companies will hire data scientists very, very early, but data engineers very, very late. I want to swap that. Because what always happens is that the data scientists will be trying to work with data that is very, very hard to work with, and they can't actually get it into the place that they need. So I told her to go out and to hire data engineers before she hires data scientists, or at least hire more data engineers than you do data scientists in the beginning. It will go very, very far when she's doing that. So then she goes out, she hires a few top-notch data engineers, she hires a few data scientists, but she tells me that she doesn't have enough time to actually label all of the data herself. And so she's constantly trying to figure out how am I supposed to be able to feed all of this information into the machine learning system if I'm trying to do it all myself. So that brought me to lesson 4, which is to leverage your users. The ability to have people that are looking at the system be able to actually interact with the system is really, really powerful, and it will 10x your ability to label the actual information that comes in. So the amount of labels goes up by a lot. What will also happen is that your algorithm will improve itself, because as the inputs from the users are fed back into the algorithm, we're actually able to improve and improve and improve. And so your actual workforce gets a lot bigger. Now, one other advantage that this has, which I think is very, very overlooked, is that it actually teaches your users as well. Many times you have phishing awareness programs, or you have all these different types of big training sessions and stuff like that. That's really one thing that is shown over and over, is that in the moment training is actually really, really useful. And whenever you're building these type of systems, the humans are actually one of the weakest points that you have. You can build the best system in the world, you can build up fortresses, whatever you want, but there are people will still be a huge failing point for your system, and you have to help them. And by having warnings in the moment of you catching the malicious emails is really, really important. So Alice does this. She builds out her system to warn about in the moment. And she comes and she says, Daniel, now what do we do? It's a good question. Now what we do is we start with the machine learning. We have enough labeled data. We're able to actually see all of the information that's coming in. We already kind of worked our muscle about understanding the problem. But what you should not do is write your own algorithm. This sounds a little counterintuitive, as I think nowadays, especially if you read a lot of blog posts, you'll see that most people think that data scientists sit around and write their own algorithms. There are enough algorithms out there that you can use in very different scenarios that are just as good. And if you follow the 80-20 law, do 20% of the work and get 80% of the benefit, go and use an algorithm that's already out there. Now, specifically for Alice's case, she has some tabular data, so data that you would go rows and columns, which you would call structured data. I'd recommend to start off with a very simple random forest. If that's not good enough, you can go to something like an XGBoost. Don't go look at it now. You can reach out to me afterwards and I can tell you a little bit more about it. And she also, on top of that, has text data, which is what you would call unstructured data. For that type of information, I'd say use pre-trained deep learning models and use transfer learning on top of it. There's some really amazing advances in the field now. Please reach out to me afterwards if you want to find out more. But the analogy that I would like to use is probably imagine going into a restaurant and you get a menu. You don't want to go into the back and try to ask the chef to make your own dish. You pick from the menu that you have, and that's what you should do here. There are enough items on the menu to solve the different problems. Just follow what is already out there. It'll save you a lot of time, and you'll get almost the exact same results, if not better. So she does that, and she builds her machine learning system using the tips that I did. So what's the problem now? Is that you actually still want to have humans in the loop here. One of the things that I think also is maybe misunderstood is that once you start building a machine learning system, you think, okay, I'm done. It's 100% machine learning. It's the greatest thing alive. That's not really true. What you really want to do is you want to have a hybrid system. So a hybrid system would be having machine learning, you have heuristics and rules. And actually with InfoSec, you also want to have, or email security, you definitely also want to have things like threat feeds. So deterministic feeds that you're able to get from the internet that will allow you to also understand whether or not emails were malicious or not. So it's actually a lot of different sources that you would use to be able to determine not just 100% machine learning. And the reason that's actually doubly important here is that fast reaction speed goes a very long way. You're going to miss some threats. That's okay. That's part of the system. It's part of the game we play. So one thing that's important is what happens when you miss it. And you have to be able to react very, very quickly. Now, machine learning systems, they take a little bit of time to actually retrain the entire thing, and to be able to react within minutes and retrain a machine learning model and get everything up and running is a bit complex, and there are a few too many things that can go wrong there. So what you want to be able to do with your hybrid system is build it in a way that you can actually react very, very quickly. So an email comes in, a company says, hey, you missed this one. Now you actually have a system that will allow you to react within minutes, and it gains a lot of confidence that even when things go wrong, you're able to really react quickly and tell them, hey, these were malicious. We actually caught these. Maybe post-delivery remediation, a bunch of different versions of catching things, reacting quickly, and then helping them, guide them to the direction in which they can block it in the future. So that's really, really important. Now, Alice did all of this, but she still had a problem, is that some companies still wouldn't sign on to her platform. And she was wondering, she said that they came back with the complaint that it seemed a bit too black boxy to them. So I told her that she has to learn to explain herself. Now, explain herself actually is threefold. One, explain the predictions that the model is making. So you have to really explain. You can't just have a black box system and assume that everyone says, okay, if they say that it's malicious, then I'm going to trust you. No, Alice, you actually have to go out and you have to explain why it is, because different companies have different risk appetites, and some of them have really, really smart, really experienced people that have different opinions about some of these things, and it's okay, and it's actually a good thing to allow them to leverage and understand why it is that you're making the decision so that they can have an input in the system. Now, the second part of that is to actually explain yourself within the company. What I find happens a bit too often is you have these kind of very technical data scientists, data engineers that are building this complex system, and the rest of the company doesn't actually understand how any of this works. Now, this is a problem because if the salespeople, your account managers, whoever it may be, if they don't understand how this works, one, they can lose confidence because they're not even really sure if it's any good or not. And two, they have a very hard time going out and selling it. So if you can actually allow the non-technical people to understand what's going on, it's a great practice for technical people and a great skill to have for technical people to explain to non-technical people how these systems work. If you can do that and you can do that well, your system will be top notch. So then she did this. She was able to explain herself, which is great. Um, which brings me to lesson number 9, which is that time from idea to production is king. Now, if you're going to remember one thing about this whole presentation, the most important one is iteration speed. I would rather have a broken system that you could iterate quickly on than a perfect system right now that takes a long time to change. This is one of those things that you don't realize that this field specifically in InfoSec is iterating so quickly, and every single time you think you've made a lock that no one can pick, someone's picked it. And if you can't now learn how to make new locks, you're in trouble. So build a system that you will be able to constantly iterate on. And one of the things that you can do is even test yourself. Set up a metric and say, okay, I have a new idea. It's idea X. How long would it take you, our team, to actually take this idea and put it into a model, put it into the system? Is it a day? Is it an hour? Is it a week? Is it a month? Look at those. There are a lot of different ways that you can actually test how quickly you can react, but that's just a good first step that I would recommend. And this really is important to making the best system, because the system that you have right now, the best system is the one that you're going to be building tomorrow, and how quickly you can get there is really the most important. So she did this. The system's looking really, really good. And she asked me, well, what do I do next? So I think the thing that I want to end with over here is to be honest, to be open, and to be humble. Companies know that your system isn't perfect. You should know that your system isn't perfect. Show them the roadmap, show them the progress. Realize that there's never going to be an end where you're going to say, hey, I'm done. So this is a constantly evolving system. This is a constantly evolving field. And just be open about the fact that you don't know everything. Customers really, really appreciate it. And so the only thing left for Alice to do actually is just to give this talk in my place. Thank you very much. Back to you, Ashley.